Okay, on this side, something a little different happens, which is, look, here on this side, I had x squared out in front, x squared, x squared, x squared, x squared. And where did that x squared come from? It came from x times x every time, x times x times x, right? That's where it came from every single time. Now, on this side, notice it's not just x squared out in front. There's a number here. Okay, so the first thing we have to do is we have to ask ourselves, is there a greatest common factor? Okay, and then after that, we can continue. But look, I'm going to ask myself, is there a number that multiplies to 5, 35, and 60? And I would have to answer, yeah, there is. A number that multiplies to 5, 35, and 60 would be the number 5. So what I can do is factor out the 5. Okay, and notice this one's going to be 2 steps, okay? And you can see you have a little bit more space here because it's going to be 2 steps. So 5 times what is 5x squared? 5 times x squared is 5x squared. 5 times what is 35? Now look, you could use your multiplication chart and say 5 times 7 is 35, or you could put in your calculator 35 divided by 5, and you would get 7 either way. So 5 times what is 35x? That would be 7x. 5 times what is 60? Again, this is where you're probably not even going to be on your multiplication chart. You could do 60 divided by 5 would be 12. Okay, and then what I observe is inside here, oh look, now I have that x squared out in front. So now look, I'm going to bring down the 5, and then I'm going to ignore it. Now I can just ignore the 5 is there, and I'm going to go ahead and do this problem the way I did on the previous page, which is this x squared comes from x times x, and I need 2 numbers that multiply to 12 and add to 7. Let's see, 2 numbers that multiply to 12, add to 7. 6 times 2 is 12, but 6 plus 2 isn't 7, that's 8. 3 times 4 is 12. Oh yeah, 3 plus 4 is 7. So we'll do. Okay, so GCF first, and then factor the other part. Okay, and remember, I had to bring down this GCF too. That was part of my answer. Okay, go ahead and pause and try the next 2 problems in that row. Let's look at this next row. Here, again, I have to ask myself if there's a GCF. So I'm asking myself, is there a number that multiplies to 3, to 15, and to 42? And the answer is yes, that number is 3. Okay, and there's something else here. In this problem, there's also an x in each term. So in this case, the GCF is 3x. So I'm going to factor out 3x. 3x times what is 3x to the third? Well, think about what 3x to the third means. It means 3 times x times x times x. So I'm already multiplying 3 times x, so I need to multiply 2 more x's. 3 times what is negative 15? Okay, well, a positive times a negative is negative. Okay, and 3 times what is 15? Now you probably just know 3 times 5 is 15. Look, you could also kind of do the whole thing in the calculator. I could say, oh, what's negative 15 divided by 3? Negative 5. Okay, and in this case, look, there's 2 x's being multiplied here. 1 x is here, right? So I'm doing 3 times negative 5, that's negative 15. And x times another x is going to get me those 2 x's. Okay, and then last 3 times what is negative 42? Negative 14. Okay, so now, same as the previous problem, I'm going to bring down the GCF, and then I can ignore it. Right, I can ignore the GCF now and just think, okay, what are 2 numbers that multiply to negative 14 and add to negative 5? This x squared is going to come from x times x. 2 numbers that multiply to a negative is going to be 1 positive, 1 negative. So when I add them, they're going to subtract. So what are 2 numbers that multiply to 14 and subtract to 5? Those numbers are 7 and 2. And since I want them to add to a negative, I'm going to make the larger number the negative number and the smaller number the positive number. Okay, go ahead and try the next 2 problems. Let's look at the next one. Right here, I'm going to ask myself, is there a GCF? And here's the thing, there's not. There's not a number that multiplies to 5 and 36 and 7. In fact, 5 and 7 are both prime numbers. So the only number that multiplies to those is 1. We're not going to factor out a 1. So there's no GCF here. So I'm just going to start like this. Okay, and here's what we know. This times this will equal this. Just like before, right? Like x times x equaled x squared. And look, just like before, this times this equaled this last number. So this times this will equal 7. Now, where did this negative 5 come from? Remember, the negative 5 came from negative 7x and plus 2x. So the 36 is going to come from the outsides being multiplied and the insides being multiplied and then combined. All right? So let's take a look. To get 5x squared, 5 is prime. So there's only one way that I can multiply and get 5, and that's 5 times 1. And then x squared is x times x. So this is going to be 5x times x. I also notice that everything here is positive, so I'm just going to go ahead and throw my 2 positive signs in here. And now I'm going to switch to pencil. And the reason is that here there's actually 2 possibilities, and the best way to figure out which one is correct is just guess and check. Okay, the 2 possibilities are so because 7 is prime, I can only do 1 times 7. That's the only way to multiply 7. So that makes 7 a pretty easy number to kind of get going with. But it could be 1, 7, or it could be 7, 1. Those are the 2 possibilities. Let's say I start with 7, 1. Look, I'm going to check. 5x times 1, that's 5x. And then 7 times x, that's 7x. Does that add to 36? No, that adds to 12. Let's try switching them. 5x times 7, that's 35x, and 1 times x, that's plus 1x, and hey, that does equal 36. So this is the correct answer, and I'm going to just go ahead and darken it in my pencil. Okay, this is a little bit harder, but remember, it's predictable. This times this equals this. This times this equals this, and the way I get that middle number is the outsides and the insides. Go ahead and try those next 2 problems. Okay, last one. First, I'm checking for the GCF. Is there a number that multiplies to 3, 11, and 20? There is not. Both 3 and 11 are prime numbers, so there's nothing that multiplies. So I'm just going to factor. And same as before, this times this will equal this. This times this will equal this. And the outsides and the insides multiplied will equal this. So it's the same as above. The only difference is here I have a negative number, so I'm just going to make it a little bit more tricky, but overall, not too bad. Okay, 3x is prime, so 3x squared is 3 is prime. So 3x squared, the only way to get 3x squared is 3x times x. I'm going to put that here. Okay, now I'm going to have to switch to pencil because to multiply to a negative, it's going to be 1 positive, 1 negative. The reason I'm doing this in pencil is I might have to switch these signs. We'll see. And then remember, the outsides and the insides are going to multiply and then add to 11. 20 is tricky because it could be 1 times 20. It could be 2 times 10. Or it could be 4 times 5. All right. So let's start to just try out possibilities and see what I get. Let's start with, I don't know, let's start with 2 and 10. So I'm going to put the 2 here and the 10 here. This is negative 30x plus 2x. Is that 11? No, that's 28, so no way. I'm going to switch the 10 and the 2. 3x times negative 2 is negative 6x plus 10x. Negative 6 plus 10, that's 4. And now look, I'm doing this in my head, but you could put it in your calculator to check. But it's not 11. So look, I tried 10 and 2 both ways. I'm going to cross off 10 and 2. Let's try 4 and 5. (3x times negative 4 is negative 12x plus 5x. That's negative 7. That's no. Remember, I'm aiming for 11 here. 3x times negative 5, that's negative 15x plus 4x. Oh, here we go. Negative 15 plus 4 is negative 11. Now, I want it to be positive 11. So what I wish is that here that I had positive 15 and negative 4. That would add to positive 11. So let's go ahead and switch. I'm going to make this the negative sign right here. This is going to be negative 4. And then this one over here is going to be positive. We'll just make it nice and neat. Positive 5. And then look, 3x times 5, that's 15x. Negative 4 times x, that's minus 4x. And that does equal 11x. Okay? So go ahead and finish these 2 problems and get checked.